Hi folks, Mr. Long here. I'm going to do some factoring for what we call non-monic trinomials. That means a trinomial where this a value here, after you've common factored, is not equal to 1. Some people call them complex trinomials. And again, trinomial because there are 1, 2, 3 terms. And again, a is not 1 after common factoring. So remember, the big idea here, though, with any type of factoring is you always common factor first. And once you've common factored, after that, you know that you have to come up with two numbers who have this property, or that have this property, that the product of those two numbers is a times c, multiplying them, and the sum of those two numbers is b, and that's related to the a, the b, and the c up here. Okay, let's do some examples. So factor and solve for the x-intercepts. So here it is. Again, first thing I'm looking for is some common factoring. And so what is a common factor that goes into 6, 14, and 12? They're all even numbers, so I'm guessing 2. But since there's a leading negative right here, okay, there's a leading negative, we should factor that out. So let's go ahead and do that. So I'm going to factor out a negative 2, which means negative 6x squared divided by negative 2 plus 14x divided by negative 2 plus 12 divided by negative 2. And that's what common factoring is. It's multiplying by 1. Multiplying by negative 2, dividing by negative 2. It's just multiplying by 1. You're not changing anything. So negative 2, and then in brackets. So negative 2 goes into negative 6 3 times, 3x squared. Negative 2 goes into 14x, negative 7x times. And negative 2 goes into negative 12, negative 6. Okay, so now we need to come up with the product. So two numbers that multiply. And you can put m or p, but two numbers that multiply to a times c. So it's going to be 3 times by negative 6. So it multiplies to negative 18, and it adds, it's a sum, or it adds to the middle term, which is negative 7. Okay, so it multiplies to a negative, and it adds to a negative. So since it multiplies to a negative, one's positive. But since it adds to a negative, the negative has to be much bigger and the positive much smaller. Or not much, but it just has to be smaller. The positive is smaller. So numbers that multiply to 18 are 1 and 18, 2 and 9, 3 and 6. So which of those numbers work? Well, I'm pretty sure 2 and 9, if you add them and the large one is negative, that's going to add up to negative 7. Okay, so those are your two factors. Okay, here's how this one works, folks. It's a little bit different. So historically, or not historically, when we were factoring regular trinomials or simple ones, we would just put x plus 2, x minus 9. But that's not adequate in this case. Because if you look at it, I've got a 3 here, right? I've got to account for that 3 somewhere, right there. That 3 has to be accounted for. So how do I account for that 3? Well, what I do is I put a 3x here and a 3x here. Now that gives me an extra 3, right? Because once I expanded this out, I'd have 3 times 3 would be 9. So what I do, I've got one too many 3's, so I divide by 3. And what I do now is I look, okay, which of those factors does the 3 go into the easiest? Well, 3 goes into 3x there, but it doesn't go into 2. 3 goes into 3x there, and it goes into negative 9 as well. Okay, so I can use this one. So I'm going to factor those out. So negative 2 bracket, 3x plus 2 stays the same, and then 3 goes into 3x, 1x times, and 3 goes into negative 9, negative 3 times. And that would be right there is your final factored form. Now I've ran out of room here to solve for the x-intercepts, but you'll notice there that process-wise it's very similar to the simple type of factoring. You just now have the extra a value that's not 1 as compared to the simple trinomial factoring. Okay, so that means that negative 6x squared plus 14x plus 12 is equivalent to negative 2 bracket, 3x plus 2 end bracket, start bracket, 1x minus 3 end bracket. Okay, that product. Those are the factors that make up that product. Okay, let's try another example. And again, you want to review this, slow it down, speed it up to make sure you've got it. So for this one here, ladies and gentlemen, I've got, let's see, it's got to multiply to 8 times 15, or have a product. So it multiplies to 8 times by that 15. Well, 4 times 15 is 60, so and then double that is 120. It has to add up to 26. Okay, so the two numbers multiply to a positive and add to a positive, so they're both positive. Okay, so what are those numbers? And this is a pretty tricky one, right? That's a pretty big numbers, right? So, you know, I could do 2 and 60. 3 goes in 40 times. 10 goes in 12. Let's see, I know it's an even number, I'll try 8, and if I use my calculator, I do 120 divided by 8, and 120 divided by 8 is 15. Oh, right there, 8 and 15. No, sorry, that doesn't, obviously that doesn't work. Let's see, what numbers work? 10 goes in. What about 20 and... 10 goes in, 20 and 6. Oh, okay, finally, that works. 20 times 6, or 10 times 6 is 60, so 20 times 6 is 120. That works, and 20 plus 6 adds up to 26. Okay, so I finally got one that works. All right, let's take a look at this one then. So what I do is I put brackets, x plus 20, x plus 6. But I've got this a value right here of 8. So that means I put an 8 there, an 8 there. That's one too many 8s, because 8 times 8 is 64, and when I expand it out, I need it to be 8. So I then divide by 8. Now what I'm looking for is to divide that 8 into one of the factors, if possible. So I check the first factor with 8x and 20. 8 goes into 8, that's fine. 8 does not go into 20 nicely. Check the second factor. Does 8 go into 8 nicely? Of course it does. Does 8 go into 6 nicely? No, it doesn't. So here's what I have to do then. What I have to do is break 8 down. So 8 goes, I can break 8 down into 4 times 2, right? So dividing by 4 and dividing by 2 is the same thing as dividing by 8. So now which of those brackets will they go into? Well, the 4 goes into the first bracket, and the 2 goes into the second bracket evenly. Okay, without a remainder. Oh, that's good then. So now I just divide it out. 4 goes into 8, 4 goes into 20. So it's going to be 2x plus 5 in the first bracket. Then I check the second one. 2 goes into 8x, 4x times. 2 goes into 6, 3 times. So 4x plus 3. And that's f at x. Okay, so that's fully factored. Now, if I wanted to set this equation equal to 0 and get the x-intercepts, I would go 2x plus 5 multiplied by 4x plus 3. And the x-intercept for that one would be at x equals, subtract 5, divide by 2, negative 5 over 2, or negative 2.5. And this one here, I have to minus 3 and divide by 4. So x would equal negative 3 over 4. And those are my x-intercepts. Okay, so this is a way of factoring non-monic or complex trinomials. The word monic, by the way, means 1. So non-monic means not equal to 1 for the a value. So in all these, in these two examples, what you have to remember is that if you've got a leading term that's not equal to 1 after you've common factored, this strategy, which is called bracket, line, is an efficient strategy. Again, there's many strategies you can use. This is just one of many. This is one that I like, but it's just one of many strategies. Okay, and now you should be able to do set 4.